In the temperate highlands of southeastern Australia, a small but remarkable creature is facing an invisible and relentless pressure. This is the mountain dragon, a lizard that can grow up to 20 centimeters long. It is a master of camouflage, blending seamlessly with the rocky terrain and alpine vegetation of its home. For centuries, these small reptiles have thrived in the cool climates of Victoria, New South Wales and Tasmania. But now, their world is changing at an unprecedented rate. The subtle, yet persistent rise in global temperatures is forcing them into a desperate search for cooler ground, a search that leads them ever upward. The problem for the mountain dragon, and many creatures like it, is that they are ectotherms. This means they rely on their external environment to regulate their body temperature. They cannot simply generate their own heat to stay warm or sweat to cool down like we can. Their very survival is tied to the ambient temperature of their habitat. As the lowlands and foothills become warmer, the conditions that once suited them are disappearing. Their only option is to follow the coolness, which means moving to higher elevations. This slow, generation-by-generation migration up the slopes of mountains is a silent retreat from an encroaching threat. This upward movement is not a sustainable solution. Mountains, by their very nature, are finite. As these lizards climb higher, the available habitat shrinks dramatically. The slopes become steeper, the vegetation sparser, and the land area smaller, culminating in a peak. It is a simple matter of geography. What happens when they reach the top? There is nowhere left to go. This phenomenon turns mountain peaks into sky islands, isolated refuges that will eventually be overtaken by the warming climate. For populations like the critically endangered mountain dragons in Victoria's Grampians National Park, this is an existential crisis unfolding in slow motion. This trend, highlighted in a new study published just yesterday on October 28, 2025, paints a concerning picture for the future of Australia's unique reptile biodiversity. The research, led by Jane Melville and her team at the museum's Victoria Research Institute, reveals that this uphill journey is a race against time. The mountain dragon is one of the first and most evident examples of this climate-driven migration, but it is certainly not the last. Understanding their plight is crucial, as it serves as a warning for what is happening to countless other species that are equally sensitive to the subtle shifts in our planet's climate system. To truly grasp the challenges these reptiles face today, scientists are looking deep into the past. They are using a fascinating field called conservation paleobiology. This discipline is like a form of ecological time travel. It combines the study of fossils with the analysis of modern DNA to reconstruct how animals and plants responded to climate shifts over immense geological timescales. By understanding how species reacted to past warming and cooling periods, we can make more informed predictions about how they will cope with the rapid warming we are experiencing now. It provides a vital long-term perspective that modern observations alone cannot offer. The research on the mountain dragon has unearthed fascinating clues from the last glacial period, which occurred around 20,000 years ago. During this cooler time, the world was a very different place. Vast ice sheets covered large parts of the globe, and in Australia, the climate was much colder and drier. Fossil evidence, specifically tiny upper jawbones of mountain dragons, has been discovered in places like Kangaroo Island and Narracoorte in South Australia. These are areas where the lizards are completely absent today. This tells us that their historical range was once much larger and located at significantly lower altitudes. These ancient bones, analysed with modern technology like micro-CT imaging, tell a story of expansion and retreat. When the climate was colder, the mountain dragons thrived across the vast, cool plains of southeastern Australia. As the planet naturally warmed and the Ice Age ended, these lizards began their long retreat. They moved away from the increasingly warm lowlands and found refuge in the cooler, higher elevations of the Great Dividing Range, where they are found today. This historical pattern of movement shows that they have always been sensitive to temperature, seeking out their preferred climate zones as the world changed around them. This journey into the past provides a critical context for the present. The historical retreat of the mountain dragon was driven by a natural warming process that occurred over thousands of years. Today's climate change is happening at a much faster rate, driven by human activity. The lizards are being forced to repeat their ancient pattern of moving to higher ground, but this time, the pace is accelerated. Conservation paleobiology shows us that while these species have adapted before, the speed and scale of current changes present a challenge unlike any they have ever faced in their evolutionary history. Beyond the stories told by ancient bones, the DNA of living mountain dragons offers another, equally compelling, layer of evidence. By analysing the genomes of modern specimens, often from museum collections gathered over many decades, scientists can see the genetic health of different populations. What they have found is deeply concerning. The various populations of mountain dragons scattered across the highlands of Victoria, New South Wales and Tasmania are now largely disconnected from one another. The once continuous range has been broken into isolated pockets, with little to no genetic exchange between them. This genetic isolation is a red flag for conservationists. When populations are small and cannot interbreed with others, they begin to lose genetic diversity. A diverse gene pool is like a toolkit for survival, providing a species with the raw material to adapt to new challenges, such as disease or changing environmental conditions. Populations with low genetic diversity are more vulnerable and less resilient. The study found that mountain dragon populations at lower altitudes, those most exposed to rising temperatures, exhibit the lowest genetic diversity, a clear sign that these groups are already under significant stress and likely declining. This genetic fragmentation tells a story of a shrinking world. As the climate warms, the suitable habitat for these lizards contracts, pulling them further up the mountains and further away from each other. The valleys between the mountain ranges become impassable barriers of warmth, preventing the lizards from migrating between populations and sharing their genes. Each mountain peak becomes a genetic island, where the population's fate is sealed by its own limited genetic resources. This isolation exacerbates their vulnerability, creating a downward spiral of declining genetic health and increased risk of local extinction. The mountain dragon is not alone in this precarious situation. The same genetic patterns are emerging in other reptile species across the region. White skink and the she-oak skink, for instance, also show signs of fragmented populations and reduced genetic connectivity, suggesting they too had much larger, more interconnected ranges during cooler periods in the past. This indicates that the pressures forcing the mountain dragon uphill are not unique. A whole suite of temperate reptile species is being quietly pushed into these high-altitude refuges, where their genetic lifelines are slowly being severed. The plight of the mountain dragon serves as a powerful case study for a much broader ecological crisis unfolding in southeastern Australia. This temperate region, particularly its alpine and subalpine zones, is a hotspot for endangered reptiles. The very trait that defines them, their reliance on external heat, makes them exquisitely sensitive to the warming climate. The blotched blue-tongue lizard, for example, is another species whose fossil record shows it once lived on Kangaroo Island 20,000 years ago, but has since retreated to cooler areas. The story repeats itself across different species, from the Blue Mountains water skink to many others. The inevitable conclusion is that there is an upper limit to this retreat. As these species continue their upward march, they are converging on smaller and smaller parcels of land. Competition for resources will likely increase, and the available habitat will continue to shrink as the warming trend persists. Eventually, for the species on the highest peaks, there will be no more mountain left to climb. They will be trapped on sky islands that are slowly being submerged by a rising tide of warmer temperatures. This is what makes their situation so urgent. Their path of escape has a definitive endpoint. This looming threat demands a fundamental shift in our approach to conservation. It is no longer enough to simply protect the areas where a species currently lives. We must also consider where they will need to live in the future. conservation strategies must become more dynamic, accounting for these climate-driven movements. This might involve protecting climate corridors, pathways of suitable habitat that connect current populations to future, higher-altitude refugees. It also means we may need to consider more hands-on approaches, such as assisted migration, where we help move vulnerable populations to new areas that will be suitable for them in the coming decades. The research published this week provides a clear and urgent message. The high number of threatened reptiles in southeastern Australia is not a coincidence. It is a direct consequence of a warming world pushing them to the brink. The fossils show us their past, and their genetics reveal their present vulnerability. Without immediate and forward-thinking action, the future for these unique creatures is uncertain. As they climb higher, we must elevate our conservation efforts to meet them. Otherwise, these remarkable inhabitants of Australia's highlands will simply run out of mountain, and we will lose them forever.